Namaste, welcome to Pythagoras Academy. I have discussed about the concept of average and average speed, instantaneous speed in one of the videos. Please do watch that before you watch this because I'm going to talk about average velocity and instantaneous velocity in continuation to that. So, what is average velocity? Consider a person moving between 2 points A and B in this random path. Say this random path has got a length of 100 kilometers, or the distance traveled by the person is 100 kilometers, and he has reached point B in 2 hours. So we have already seen how to find out average speed and instantaneous speed. Now what is average velocity? Velocity is a vector. It has got both magnitude as well as direction. So when you're talking about velocity, simply saying the magnitude is not complete. So when you talk about velocity, you have to say it's like 30 km per hour along east or along north. So you have to specify the direction, otherwise velocity is meaningless. Now in this case, if you apply the definition of average, if you observe the person is changing his magnitude as well as direction of path at every point. Because he is changing the direction, it is curvy path. Had he moved in with the constant direction, the path would have been a straight line, a simple straight line. Because he is changing his magnitude as well as direction, he is moving this curvy path and reaching point B. So average velocity is, had the person moved with constant velocity. When I say constant velocity, it is constant magnitude and constant direction. When it is constant direction, the path is already defined. It should be a straight line path. It means, had the person moved with constant magnitude of velocity along the straight line, what is that value and what is that direction, so that he reaches from point A to point B in the same time, 2 hours. Definitely the direction is very clear. From point A, if the person has to reach point B traveling in a straight line, the only possibility is this: he has to go along a straight line which is joining A and B. There is no other way. So the length of the line joining the initial and final points is known as displacement. So velocity is always connected to the physical quantity displacement, which is the length of the line joining initial and final points and directed from initial point to the final point. So average velocity, I can define this as total displacement by total time. It is total displacement because displacement is a vector. I'll keep this symbol to say that it's a vector. Or I'll write, this is say x bar by t. This is the average. For example, the length of the line joining initial and final points is 60 kilometer. Then what is the average velocity of the person in this particular case? It is 60 by 2, which is 30 kmph, 30 kilometer per hour along the line AB. You have to be very specific with the direction. So the average velocity of the person is 30 kilometer per hour along the line AB, so that he'll cover 60 kilometers in 2 hours to reach the point B. Now talking about instantaneous velocity. So what is instantaneous velocity? The velocity at a particular instant of time. Suppose at this instant, at this particular instant, I have to calculate the velocity of the person. It's like I have to take the snapshot at this point. So by the time you take the snapshot, delta t amount of time is elapsed and the person is already here. So he has covered a distance of delta s, and then there is a displacement of delta x bar. So I'll again zoom this part. It is like this. This is the small distance delta s, the length of the line joining initial and final points. This is the small displacement delta x bar. As far as the instantaneous velocity is concerned, so I have to find the velocity at this instant. So I'll calculate the average in this small time. The average velocity in this small interval of time is delta x bar by delta t. When this delta t is tending to 0, just like we found the instantaneous speed, when delta t is as small as 0, when delta t is approaching 0, the average becomes instantaneous. So instantaneous velocity I'm representing with v bar. So v bar E is nothing but, this is nothing but differentiation of x bar with respect to t. You can use x bar or r bar, whatever it is, which is rate of change of displacement with respect to time, or it is derivative of displacement with respect to time mathematically, dx bar by dt. This is instantaneous velocity, or velocity at a particular instant of time, or simply velocity. Every time you don't have to use the word instantaneous, it is simply velocity. Now, if the instantaneous velocity is zero, if the instantaneous velocity of a particle is zero at a particular instant, can I say the average velocity to be zero? What does it mean? Instantaneous velocity in the sense, at one point of time, the particle may come to rest. It is not moving. At that instant, it is zero. It doesn't mean average is zero. If instantaneous velocity of a particle is zero, it doesn't mean the average velocity is zero. It's like in one subject, if you get zero, it doesn't mean your average score is zero. Do it the other way around. If average velocity of a particle is zero, is the instantaneous velocity zero? If average velocity of a particle is zero, what is zero? The total displacement is zero. Then is instantaneous velocity zero at every instant? Think of it and keep your answers in the comment section. We'll try to discuss in some other video. Thank you so much.